Hi dear students and viewers, welcome back. Hi guys, in this video we are going to discuss about the introduction of the kinematics, motion in a straight line or motion in one dimension chapter. In this video we have to know about the first thing is what is mean by one dimensional motion and what is mean by two dimensional motion and what is mean by three dimensional motion. And what is the frame of reference and how many types of frames of reference are there, and what is the distance and what is the displacement, and how the problems will be given in our examinations. Let's discuss all these things with very clear examples. Before going to start the lesson, dear students, one request is from my side, that is, if you are first time if you are watching the video, then subscribe my channel and press the bell icon too. Clear? Dear students, I already uploading these so many online examinations of Eamcet, Neet, JEE in my app VINAY KUMAR Basics of Physics, that is available in Google Play Store. That's why you can download the app also. In that app you are going to be learn so many new courses, online courses are there, and online tests are also there. That's why you can download the app also. Okay children, now coming to the point, what is mean by kinematics? The branch of mechanics that can explain about the motion of the body without taking the force which is acting on it. That should be called as kinematics. Kinematics can explain the motion of the body which do not consider as a reference which is the cause of motion. That is could be called here kinematics. So dear students, here what is mean by one dimensional motion? If the motion of the body is confined to any particular one axis, either it is horizontal or vertical. If you are throwing one object horizontally, or if you are throwing any object in vertically, horizontally means we are using the x-axis, vertically means we will take the y-axis as the reference. Simply what you have to say, the motion of the body can be explained with respect of any one axis. That should be called as here one dimensional motion. Clear? If you can explain the motion of the body by taking the two axes as reference, that should be called as here two dimensional motion. We are explaining the motion of the body with reference of any two axes. That should be called as here two dimensional motion. The billiard balls, while playing the billiards, in that balls are in the two dimensional motion. Clear? And now three dimensional motion. If the body is moving in particular a plane, the motion of the body can be explained with respect of three axes. That should be called here three-dimensional motion. Projectile motion of the body or the motion of the body in a air, that should be taken as best example for three-dimensional motion. So this is simply about the types of motion with respect of their axis. And next thing is what is mean by frame of reference. Frame of reference. Here the coordinate system which can be used to explain the motion of the body, that should be called as a frame of reference. For example, here the simple frame of reference is XYZ. It is the X and this is some Y axis, and now it is the Z axis. There is some point X, this is the Y and this is Z. In that plane we are taking some P is the point, that should be shown as P of X comma Y comma Z. Now this X, Y, Z is called frame of reference. Frame of reference. The coordinate system that should be used to explain the motion of the body is called frame of reference. The frame of reference should be divided into two types: inertial frame of reference and non-inertial frame of reference. Inertial frame of reference means the frame of reference or the reference frame which can obey or valid Newton's laws of motion. Newton's laws of motion. That should be called as inertial frame of reference. The reference frame or the frame of reference which can holds the Newton's laws of motion, that should be called as here inertial frame of reference. It means that the frame of reference must be either it is in rest position or frame of reference must be in uniform motion. Then only Newton's laws are valid. Clear? And now non-inertial frame of reference. Non-inertial frame of reference. The frame of, in which frame of reference? In which frame of reference Newton's laws are not valid, that should be called here non-inertial frame of reference. Clear, children? Let's see what is mean by point object, why we can use the point object in kinematics. Here what is mean by point object and what is the distance and what is the displacement. Let's discuss in detail. Point object, generally in a one-dimensional motion, the body should be taken as a point. Why? Because the size of the body must be less than the distance traveled by the body with the time. Even the earth should be taken as a point object during its revolution. Why? Because the revolution, the distance traveled by the earth, that should be more than its size. That's why earth can be taken as a point object. Clear? So size of the object is less than the distance traveled. That's why every object should be taken as the like point object. And next, coming to the point here, distance. What is mean by distance? The path followed by the body. The path followed by the body in its motion is called distance. So for example, here this is the starting point A. Clear? The body moves like this. So its position is, I am saying, going to say this is the B and this is the C and this is the D and this is the E. Clear? So the path travel like this: AB to BC, BC to D and D to E. That should be here path followed. Distance, what is A, B, C, D, E. For example, if you can say that A to B is 20 meters and B to C is 30 meters and C to D is 40 meters and D to E is some 50 meters. So then obviously the total distance is what here? 20 plus 30 plus 40 plus 50. So 20 plus 30, 50. 50 plus 50, 100. That is equals to what? 140 meters. 140 meters. That's why here the distance is always positive. Distance is always positive. It never be 0 or negative. Never be 0 or negative. That's how to remember. Distance is always positive. It never becomes 0 or negative. And you have to remember, distance is the scalar. Distance is scalar quantity. Distance is the scalar quantity. And the dimension formula is here simply m to the power of 0, L and t to the power of 0, and units are again SI units we have to take, that is meter. Clear? Distance is what? The path followed by the body in its motion is called distance, and distance is a scalar. Its dimension formula is what? L and units are meter. Now coming to the displacement. Clear? So this is the starting position and this is the final position. If you can join these two, it is a straight line. Now here A is the, what is displacement. A is what? Displacement. A, B, C, D, E what? Distance, and A is the displacement. A straight line joining the initial point and final point, that should be called as here displacement. Clear? So here displacement is nothing but shortest distance between 2 points. Shortest distance between 2 points is called displacement. Here A to E, it is the shortest path. That's what it is called here now, displacement. Clear? And dear students, for example, at the time t1 its position is x1, at the time t2 its position is x2. Then displacement is here, we can write displacement is equals, we can write x2 minus x1, x2 minus x1. Here displacement's possibilities are like this. If x2 is greater than x1, displacement is positive. Clear? And if x2 is less than x1 or x1 is greater than x2, then displacement is negative. And if x1 is equals to x2, displacement is 0. There are three possibilities here. But in case of a distance, only the distance is positive. Distance is positive. And now in this case, displacement is what? It is maybe positive or maybe negative or maybe 0. Displacement should be written as here x2 minus x1. When x2 is greater than x1, displacement is positive. When x1 is greater than x2, displacement is negative. When both are equal, then the displacement is 0. And again, as usual, for displacement is a vector. Displacement is a vector quantity, and it has same dimension formula like distance. M to the power of 0, L, T to the power of 0, and units are SI units are what? Meter. SI units are what? Meter. Clear, children? So this is the difference between the distance and displacement. But there is one common point in between these two is when the body is moving along a straight line path, then distance and displacement both are equal. To understand the distance and displacement, we will discuss some example problems. A person or moving body moves from A to B 4 kilometers towards east and from B to C 3 kilometers due north. Then find distance and displacement traveled by the person. Some options will be given. A person is moving from A to B. A to B was moving here. For example, I am saying now this is the A and it is B. Clear? So what he was given, we have to draw some directions. So this is the north, south, east and west. Clear? So a person or body moving from A to B 4 kilometers. This is 4 kilometers. 4 kilometers towards east, and after that 3 kilometers north. So like this, 3 kilometers. This is now C, 3 kilometers. That is the situation. Then what you have to find out? We have to find out the distance and displacement. So what is the distance? Path followed by the body is called distance. Here simply we can write distance is equals to, what is the path here? First he was moving along the A to B and again B to C, B to C. AB how much distance? 4 kilometers and BC 3 kilometers. 4 plus 3 7 kilometers. Clear? And now what you have to find out? We want to find out the displacement. So initial point is A and final point is C. This is the shortest path between S, A and C. Here this is the angle is 90 here. Then obviously according to the Pythagoras theorem, what do you write? Hypotenuse square is equals to side square plus side square. Here hypotenuse is nothing but AC. That is the displacement here. AC square is equals to one side is AB square, one side is BC square. What is AB here? AB value is 4 whole square plus 3 whole square. Clear? So obviously here now what to write? AC displacement square is equals to here 4 square 16 plus 3 square 9 25. That is equals to what? 5 whole square. Therefore AC is equals to 5 kilometers. So that is the displacement here. Distance is the 7 kilometers and AC is equals to what? 5 kilometers. kilometers. So dear students, in this case, maximum times if the motion of the body is along the straight line, then the distance and displacement both are equal. Other than the straight line, then the displacement is always less than the magnitude of distance. That's you have to remember. So in this way we can find out the distance and displacement. Clear? Let's see one more example. Let's see the next problem. A man starts from his home and walks 50 meters towards north. Then he turns towards east and walks 40 meters and then reaches to his office after moving 20 meters towards south. What is the total distance covered by the man from his home to office, and what is his displacement from his home to office? A man starts from his home and walks 50 meters towards north. Then he turns towards east and walks 40 meters and then reaches to his office after moving 20 meters towards south. What is the total distance covered by the man from his home to office? What is the displacement from his home to office? That is the problem here. We want to find out the distance and displacement here. The first thing, we have to draw the directions like this. So obviously this top is north and bottom is south, and this one is east and this one is west. Clear? So what he was saying, first he was started towards moves north, towards north 50 meters, and then after he turns towards east. So this is the 50 meters and now turns 40 meters. Here it is 40 meters and reaches to his office after moving 20 meters towards south. So this is towards north, this is north, and this is towards east, and next one is towards south. How much distance traveled here? 20 meters. So at this position is home. This position is home and this position is office. Clear? So obviously what you will find out, we want to find out the distance and displacement. Here I am saying this is A and this is the B and this is C and this is D. Now what is the distance? Distance is equals to here, what is AB plus BC plus AB plus BC plus CD. So AB is what? 50 meters and BC is what? 40 and CD is 20. 50 plus 40, 90, 90 plus 20, 110 meters. So distance is what? Distance is what? 110 meters. Now what you have to find out? We want to find out the displacement. That is what here we want to find out this one. This is the like this. AD is the displacement, we have to find out it. And I am going to draw the normal like this. And this should be like this. Here I am saying AD, C something whatever maybe. From this figure what you have to say? BC is equals to AE. BC is equals to AE. That is what? 40 meters. And this is the 50. Already is from figure. AB is equals to DE. AB is equals to what? C. AB is equals to C. AB is equals to C. But in this case here what is the value of DE? So C is equals to what? We don't know, that is what here some CE is equals to what? We don't know here, but C is equals to what? We are saying AB. That is what? 50 meters. In that what it is, I am going to write C is equals to CD plus DE. CD plus DE. CD is what? 20 and C is what? 50. And what is DE? So 50 minus 20. 50 minus 20, that is equals to D here. 50 minus 20 means 30 DE. So here now this is 30 meters and this is 40 meters and this is the angle. Then again as usual, Pythagoras theory. What it is? Hypotenuse is AD, that is the displacement here. AD square is equals to DE square plus and AE square. So here AD is the displacement. AD square is equals to D means what? 30 whole square plus, and A is what? 40 whole square. So that is equals to what? 900 plus 1600, and that is equals to what? 2500. That means what? AD whole square is equals to 50 whole square. Then AD is equals to what? 50 meters. Displacement is what? 50 meters. This is 50 meters. So distance is how much we got? 110 meters, and displacement is what? Is 50 meters. So here AD is displacement that should be less than the distance. Okay. Okay, see the next problem. An object covers 1/4 of the circular path. What will be the ratio of the distance and displacement of the object? An object covers 1/4 of the circular path. What will be the ratio of the distance and displacement of the object? So this is the one circle that should be having some radius r. Clear? So this is the one point and this is the another point. Clear? An object covers 1/4 of circular path. So this is the, here obviously it is moving from here to here. So from here to here is particle is moving. Clear? And this is, I am going to say, this is the AB is the distance. AB is the distance. And now this is the displacement. So to understand simply here, I have to draw the like this here, 4 parts. So obviously this AB is the distance and this straight line is the displacement. So this is the distance and this one is displacement. So we have to find out the ratio of these two. For example, I am saying this is AC now. AC is the displacement. So obviously this is the radius and this is also radius. So obviously here this is the total circle. For one rotation, the distance covered is what? Per one rotation, distance is what? 2 pi r. 2 pi r. In that 1/4 is covered. 1/4 is covered. That means what? Distance here, what you have to write? Distance is what? 2 pi r by 4. 2 pi r by 4. Here 2 ones are 2 2s are. That is what? Pi r by 2. So distance is what here? Pi r by 2. That is one step. And second one is what? We want to find out the displacement. So obviously here I am going to draw like this, simply same diagram. This is the r and this is the r. Again according to Pythagoras, I am going to say this is the x is the displacement. X is the displacement. Then what write according to Pythagoras? X square is equals to r square plus r square. Then x square what it is? 2r square. 2r square. Then what it is? Obviously x is equals to what? r root 2. R root 2. So what you will find out? Ratio of distance and displacement. Distance is what? Here we can write distance by displacement. That is what? Distance is how much? Pi r by 2 by r root 2. R root 2. Here what write? Simply pi r by 2 root 2 r cancel. Pi by 2 root 2 is the ratio of the distance and displacement. Clear? Dear students, if you can understood this content what I was explaining in this video, then please like, share, comment the video and share my channel and my app to your friends. Then only it is useful to so many people, and that is also useful to me, and that is the motivation for me actually. That's why if you want to get the more videos from my channel, please support my channel and share my channel. Thank you for watching. Bye. Take care.